હેલો એવરીવન. સો લાસ્ટ ટાઈમ આપણે હોમોજીનિયસ ફંક્શન શું છે એ વસ્તુની ડેફિનેશન જોઈ હતી. એના રિલેટેડ અમુક એક્ઝામ્પલ હોમોજીનિયસ ફંક્શન આઈડેન્ટિફાઈ કરવા, કઈ રીતે ફાઇન્ડ કરવું હોમોજીનિયસ ફંક્શન, આપેલ ફંક્શન જે છે 2 વેરિયેબલ અને 3 વેરિયેબલ ફંક્શન્સ હોમોજીનિયસ છે કે નહીં એ વસ્તુ આપણે ચેક કર્યું હતું. ધેર આફ્ટર there is another theory that is Euler's theorem. સો એ થિયરમની અંદર હોમોજીનિયસ ફંક્શન સમજવું ખૂબ જ જરૂરી હતું. એટલા માટે આપણે પહેલા હોમોજીનિયસ ફંક્શન છે ડિસ્કશન કરેલું. હવે આ પાર્ટની અંદર આપણે જોવાનું છે યુલર્સ થિયરમ. સો યુલર્સ થિયરમની અંદર હોમોજીનિયસ ફંક્શન છે એ શું ભાગ ભજવે છે એ આપણે જોશું અહીંયા. સો ફર્સ્ટ ઓફ ઓલ યુલર્સ થિયરમનું તમને સ્ટેટમેન્ટ આપેલ છે. ઇફ યુ ઇઝ ફંક્શન ઓફ x and y, if u is function of x and y is a homogeneous function. Now suppose we have identified that this function is homogeneous, then homogeneous function of two independent variable x and y, if degree n, then Euler's theorem says that x del u by del x plus y del u by del y is equal to nu. Now n is your degree and u is your original function. Clear? So if you have this statement as a homogeneous function, then you can prove that by Euler's theorem that x del u by del x plus y del u by del y is equal to nu. This is for two variables. If I will take a three variable, that is u is equal to f of x y z, then this statement of Euler's theorem proves that the x del u by del x plus y del u by del y plus z del u by del z is equal to n into u, where n is your degree of particular homogeneous function and u is your original function that is given by here. Clear? So similarly one by one આપણે એક એક્ઝામ્પલ જોશું અને then after Euler's theorem જે છે એ આપણે પ્રૂવ કરશું. So in this problem you have given a statement. If u is equal to sine inverse x and y, now u is function of two independent variable, that is x and y. So if u is equal to sine inverse x upon y, then find x del u by del x plus y del u by del y. Clear? So just તમારે શું કરવાનું છે, યુલર્સ થિયરમ એટલું સિમ્પ્લિફાઈ કરીને આપે છે કે તમારે આ જે del u by del x અને del u by del y જે છે એ તમારે ફાઇન્ડ કરવાનું રહેતું નથી. ડાયરેક્ટલી એના રિઝલ્ટ ઉપરથી તમે એનો આન્સર જે છે એ આઈડેન્ટિફાઈ કરી શકો છો, જે સ્ટેટમેન્ટ આપણે હમણાં જોયું. સો ફર્સ્ટ ઓફ ઓલ તમને ફંક્શન આપી લીધેલું છે u is equal to, now we'll start solution. Function is given u is equal to sine inverse x and y. So first of all તમારે આપેલું ફંક્શન, આ જે ફંક્શન છે એ હોમોજીનિયસ ફંક્શન છે કે નહીં એ જસ્ટ આઈડેન્ટિફાઈ કરવાનું છે. સો ફર્સ્ટ ઓફ ઓલ તમે ફાઇન્ડ કરશો સ્ટેટમેન્ટ f of del x del y is equal to, now you have to replace x and y by del x and del y, lambda x and lambda y. So f of lambda x lambda y is equal to sine inverse, now you can say that this function is f of x comma y. Okay, so sine inverse lambda x upon lambda y. Clear? So lambda is cancelled, so function is sine inverse x upon y, where the constant lambda has the power 0. So we can say that the given function u is equal to sine inverse x and y is homogeneous function of degree n is equal to 0. So by Euler's theorem x del u upon del x plus y del u upon del y is equal to n into u. Clear? So now you have value of n, so put the value of n, that is 0 into u, that is 0. So answer will be this, x del u by del x plus y del u by del y is equal to 0. Clear? So similarly another example આપણે જોઈએ. You have given another statement is like, if u is equal to root x root y into bracket x raised to n plus y raised to n, then you have to find the Euler's statement, that is x del u by del x plus y del u by del y. So first of all I will write the statement that is given by u is equal to root x plus root y x raised to n plus y raised to n. Now you have to just prove either this function is homogeneous or not. Clear? So that's why now uh, I will identify this function as a f of x comma y, because this is the two independent variable of function. So now f of lambda x lambda y is equal to, now replace x and y by lambda x and lambda y, then you have lambda raised to 1 by 2 x raised to 1 by 2 plus, you can write root x by x raised to 1 by 2. Similarly, lambda raised to 1 by 2 y raised to 1 by 2 into bracket lambda n x raised to n plus lambda n y raised to n. Clear? So now common out from this side lambda and from this side lambda raised to n. So now you have lambda raised to 1 by 2 x root x plus root y lambda raised to n x raised to n plus y raised to n. Clear? So now this both lambda, the base is same, but the power of the lambda is not same, so we can write as n plus 1 by 2 into root x plus root y into x raised to n plus y raised to n. So simply I can write lambda raised to n plus 1 by 2 into f of x comma y. So therefore from this statement I can say that the given function u is equal to this function is homogeneous function of degree n plus 1 by 2. Clear? So now you have a degree n plus 1 by 2. Oh, so given function is I will not write the given function is homogeneous of a degree n plus 1 by 2. Simply I can write that degree is n plus 1 by 2. Now from the Euler's theorem, del x by del y, x del u by del x plus y del u by del y is equal to n into u. Now n is your degree. Now you have to replace n by n plus 1 by 2. So just that is x del u by del x, y del u by del y is equal to n plus 1 by 2 u. This statement. Clear? So this is the final answer of the given problem statement. Similarly, I will take some another example based on Euler's theorem. Then you can see that how Euler's theorem can be applied. So another statement is given here that if u is equal to cos in bracket xy plus yz plus zx upon x square plus y square plus z square, then you have to show that x del u by del x plus y del u by del y plus z del u by del z is equal to 0. So you just have to prove this statement, that is Euler's theorem of three variables. Okay, so first of all I will start the solution. Now first of all I have to prove this either this function is homogeneous function or not. So just write down u is equal to cos xy plus yz plus zx upon x square plus y square plus z square, that is equal to f of x y z. Clear? So first of all I will prove that either this function is homogeneous or not. So I will take lambda f of lambda x lambda y lambda z is equal to cos, now replace xyz by del x del y and del z. So you have cos lambda square xy plus lambda square yz plus lambda square zx. Why? Because we have to put x by lambda x and y by lambda y. So lambda is equal to lambda into lambda, that is lambda square. So I put it directly lambda square. Clear? Upon lambda square x square, lambda square y square, lambda square z square. Now similarly, common out from the numerator, you have just lambda square, and upon in denominator you have lambda square also. So lambda square and lambda square are cancelled. So I can just write down cos xy plus yz plus zx upon x square plus y square plus z square. Clear? So similarly, I can write that lambda raised to 0 f of x, y, z. So I can say that the given function u is homogeneous of degree n is equal to 0. So from the Euler's theorem statement, the degree is n is equal to 0. So that's why by the Euler's theorem, x del u by del x plus y del u by del y plus z del u by del z is equal to n into u. So now you have n is equal to 0. So you just put, therefore x del u by del x, x del u by del x plus y del u by del y plus z del u by del z is equal to 0. So this statement is proved. So this is your answer. Clear? So similarly we can solve by using the Euler's theorem. So in next part I will show how the Euler's theorem satisfies their conditions, and I will prove the statement of Euler's theorem.